Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. And I'll be completely honest, I don't super remember what I wanted to do, but I feel like I had wanted to implement a little snake creature, and we never really got around to that. So, and I think we also were gonna make the familiar float around too. So I feel like we're still gonna do some more brain programming, just to make sure that that API, or I shouldn't say API, but architecture decision pans out reasonably well, and that there's no hidden surprises there. And I know we did the Monstar and we've done the hero, but doing the familiar and a little snake creature, I think, would just be a good idea to make sure that that's all it's all kosher. Anyway, if you are following along at home, today is day 292, so you can go ahead and unpack day 291 source code interdirectory if you want to follow along with today's programming, and, you know, I highly recommend that you do. So here comes our project. We will build, and we will load. Here we go. And run. So I think we just have a Monstar hopping around, yeah. And then we've got my hero here, and he's kind of moving around too. So we've got all those guys working. But if I remember correctly, we had not yet we don't have currently a floating method of movement, and we do want a floating method of movement for this little fellow right here. Mini-Me, I guess, might be a good name for him. So we want Mini-Me to be able to kind of float around. Yeah, I feel like that shouldn't be too hard to add in there. And then the other thing that we're going to have to do as well is I would like to make that snake creature, and so I don't know what we'll make the snake creature out of. Maybe we'll make the snake creature out of these little heads as well. I'm not sure. Anyway, so let's go ahead and see what's going on there and figure out if we can get our familiaring itself around in a nice, pleasant fashion. So here is the code for all the brains right now. And here's the code for the familiar, and you can kind of see it doing its thing here. You can see that it figures out roughly where it thinks the closest hero type thing is, and then it does like a it does a little sort of what direction would I go to get there sort of a thing, and tries to make that happen. Now, I don't actually know. We have not stepped through any of this code, so we don't know what any of this stuff is doing. And furthermore, we don't set a movement mode on this character, so really the movement of it, I think, would immediately get negated anyway. Because if it's set, I don't actually remember. Let's take a look. Because we've got these movement modes in here, right? There's planted and hopping. And I seem to recall that planted things will snap themselves to their occupying location, I feel like, if they have one. And so we probably need like a movement mode, you know, floating kind of a thing, to make that be okay. And now, I'm just going to go through, because I think, again, oops, it's not in there. I want world mode. We haven't really sort of nailed down the movement mode stuff anyway, and I think that maybe needs a little bit more attention to detail. Okay, so you can see there, it's not even doing that operation that I said that it should do. It's not doing that at all, so that's something that probably should have been fixed anyway. You can see the move entity call here, and that's using the entity DDP, so I would have thought, and I guess I don't have to add this yet because this, I should be able to debug. This should actually be working as it is. So this guy here, we just need to figure out what is wrong with setting his DDP so that he can move towards the hero, because he should be getting some sort of acceleration there or something, and we're not seeing that. So the question is, you know, what do we do to make that happen? All right. So first things first, we've got this acceleration over square root thing here, and that term is designed to make it so that our acceleration is going to point in the direction of the closest hero and be the length that we specify in acceleration. Now, the first thing that I noticed there is I wonder if that acceleration is too low. So before we start debugging anything too fancy, I'm just going to crank it up huge and see what happens, just to make sure that it's not just a low value problem, right? So you can see that the head's not moving. So with that kind of a push on it, we can be fairly certain that it's not, that it's basically it's being ineffectual, right? I suppose the other thing I should double check first, and then I'm going to go ahead and step in because I don't want to guess for too long. I can just step in and see what's going on. I also want to see what happens in add familiar. Want to make sure that we're actually adding the brain and it's correct and all that. And it does look like it. So I'm going to take a look at that code and see what's happening inside that code for the familiar's brain, I should say. And just want to make sure that it's setting it to something that makes sense. So here's the game running. There's the familiar. We should see it creating a vector that points off towards the hero, and let's just make sure that that's actually happening. And that is not in any way even remotely happening, in fact. So why not? Because we did set this to true. Remember, right? We turned that on. So we go through our entities here, and we're looking to see if they have these slots. In fact, that's getting set. Is it just that it's the closeness? It's too far away, I guess? Is that the problem? I guess that must be the problem. Let's find out. Closest hero d squared is now set to 0. How is that possible? So the test entity minus our head is somehow evaluating to 0 for something with a brain slot type of hero. I am very interested to know more about this. So here's what I'm going to do. I'm going to step out to there, and now I'm going to step through all of these, and I'm going to see what's going on here. Here's my watch window, and here's my test d squared. So there it is at 48, there it is at 35, 25, 39, 25, 15, 33, 19. And, I'd also point out, yeah. So the fact that I just had that bug, and I'll tell you what it is if you didn't already notice. Type brain hero is just the default value. Remember I said we don't need a default value there? Well, that pretty much tells me the fact that I can have that bug, right, which is just a stupid bug that we don't want to have, tells me that brain type, if in case I'm ever looking at brain type, what I probably should do is either make it so that there actually is a null brain type, or so that when you get the brain type, it has to actually have a brain ID. And I think I do want that to be the case, meaning I think I want you to have a brain assigned, because if you happen to still have a brain type, but you don't actually have a brain ID, that doesn't really exist per se at that point. So I got to think about how I want to do that. So instead of brain slot type, I want to do something like an is type here, where I say brain slot and I say that, right? Something like this. And that way, when we have these brain slots here, I can just make it so that if the type it matches, the index still has to be non-zero. Does that make sense? So basically, there'd be like a B32 here that's like is type, and I say here is the slot, and then what the type is that I want. And then the result of that is just that it has an index, and the type is the same, right? So that is better, because now we're not gonna. It was gonna return all kinds of false positives before. So there we go. And of course, we're going to get a max entity velocity violation there, where our assertion that things shouldn't be moving too quickly, because we're going to have to go return the ridiculous acceleration on this guy down to something not so ridiculous, as it were. Okay. So yeah, we're going to have to tune this guy's motion. And the other thing, too, is we probably want him to slow to a stop. Like right now, what he's doing is he's kind of doing some weird stuff. He'll be doing some very strange things where, like, he'll just stop moving entirely if we're out of range and other stuff like that. So we probably want to clean up this code to a certain extent, right? So, yeah, and in fact, I should also say that in the entity code, that actually brings up a good point, which is that in the entity code, we don't call move entity if your acceleration is not greater than 0, but we also probably want to check to make sure that your velocity isn't greater than 0, because otherwise you should keep moving, right? And so that should be more like this, certainly. Okay, so yeah, if we take a look at what's happening here, this dude doesn't have any drag on him right now. So he kind of is just going to accelerate to random places. He'll orbit us, basically, is what he'll do, right? Because he has no drag and he's not attempting to stop anywhere. So he'll just keep orbiting us indefinitely, I guess pretty much always. And the eccentricity of the orbit, I guess, would be something related to the entry velocity that he had, I think. You can kind of see now he's sort of doing a very, like, triangular weird thing. And that's because when he's close to us, he's not accelerating at all. But when he gets far away from us, he accelerates back toward us and, again, produces that sort of orbital like mechanic there, right? All right, so that's that dude. And we've got a little bit more to do with this dude, right? Because, again, we want to introduce movement modes for all the guys that do that transactional move stuff properly. Because what you can see is we're not updating his occupying square. And so we don't want to just shove the velocities into things willy-nilly. We want those velocities to, as the head moves, we want those to be things that sort of properly track which square the guy's on, and don't let the familiar go into squares where there isn't room for him, right? So, for example, he shouldn't be able to go into that square, right, that I'm on. But right now he can do anything that he wants in that respect, and that's no good. Furthermore, of course, I can't enter this square, right? You can see I always hop over it, which is also not right. So we need that space to update always. All right. So, we've got a bunch of work to do here, and I think I want to work on these movement modes. But first, I'm going to finish off my brain stuff here, and I'm going to create this snake dude, right? Because I want a snake dude. So I'm going to do like an add snake thing. We got like add monstar and junk like that. I'm going to do an add snake. And let's see. What I want to do with add snake is I want to be able to drop like snake pieces. So, technically I should probably call this add snake piece, right? And what I want to do is take exactly the stuff that was happening before where we're placing pieces. We're going to do exactly the same thing, and essentially we're just going to add a monstar. In fact, we could even keep hit points on there, right? And I'm going to use instead of a torso, I'm going to use a head. And but otherwise things are going to be the same, and it's going to do exactly the same stuff that it was doing before, only it's going to cause a brain snake to be created for this guy. And instead of adding the brain, I'm going to have the brain ID be passed in. And the reason for that is I want all the pieces of one snake to have the same brain ID, so they'll get aggregated up and can be used, all be attached to the same brain. All right. So let's see here. I don't remember what I call this, or even if I had one of these yet. I thought I did, but I might not. So let's see. You can see I've got type brain snake here, but of course my macro is going to require that I have an actual thing here as well. And so I'm going to say, all right, snake segment, and we've got a bunch of segments, and I don't know how many there should be exactly, but I guess there will just be, you know, I'm wondering too, do we use this really anymore? The array 16 thing? I don't know if we do. Anyway, because well, it doesn't matter. I guess we kind of do, because we need to pack them, so it's fine. Oh wait, no, we don't. We don't even pack them. Yeah, we might be able to just get rid of that. I'm wondering. Okay, so bear with me here for a second, but let's say that the maximum number of snake segments is 8. Just bear with me for 1 second, because I want to know the answer to this question. Brain slot for segment, and I guess in here we'll have segment index. And so this brain slot 4 thing is also going to be a little dicey, right? We're probably going to need a brain slot or like an indexed brain slot 4, where we can say like it's the segments thing, but it's actually an array, so we've got an index, right? Something like that, right? But okay, so I got a couple things I want to do now that sort of came up as a result of this. So let's go into the brain, and you can see the brain slot 4 stuff. The problem here that we would have is we need that to be a constant, and if we're passing it to a function, it's not going to be constant. Now, it's pretty easy for us to have the indexed version of this. It's really trivial. So if we have, you know, indexed brain slot 4, all we need is the index on here. We could just say, like, well, whenever you get this member, whatever it is, right, just go ahead and add however many forward you wanted to go, right? Whatever the index was, just go ahead and add that in. And that should be sufficient, if that makes sense. All right, so let's compile that. Requires an L value. Does it? Where am I? That's going to be in here. Let's see. Wait, what? Oh, sorry. Parentheses. It's like a Lisp. It's like programming in Lisp all of a sudden. Let's see. Entity star 8 and entity star star. So I guess I'd probably have to ask specifically for the. I'd also have to ask specifically for the. Well, or I can just get rid of the ampersand, which actually seems smarter. Right? So I can just make it a simpler expression. So yeah, got closed. Is that right? And let's see here, converting from int64 to u16. Okay. So the pack value, we would have to guarantee that it's a U16, but that seems pretty reasonable. You can see what's happening here, right? This index value, we now no longer, before the compiler could tell what this offset was at compile time, now it can't, right? Because of the index. And so, well, you know what I could do? This is actually a lot simpler. What I could do is just say, oh, indexed brain slot 4, it just could call brain slot 4, right? It could be the exact same expression. And when I pass that that second value, I could just add the index as a U16 right here, right? Because whatever that index value is, we're just going to increment it up from there. So I don't really know why I didn't think of that originally. That's way easier, right? So yeah, that's the right way to do it. And then I just have to take care of the fact that you don't really need to take the address of this guy. So it's not an address anymore. All right, so what's the problem here? This is a U16. I guess I've got to tell it this is a U16 as well. Brain slot 4 function does not take 1 arguments. Okay, but I'm not passing it 1 argument. What is the problem here? Pointer can only be subtracted from another pointer. Oh, I just love trying to program in C++. All right, so let's see. This has to do the subtraction first before I can add. There you go. And this is a pointer. So I'm not sure why that would be a problem. Right, that is already a pointer. So I guess that was just my cast with being in the wrong place. There we go. Man, that was arduous. All right, so before we get to the snake part, what I wanted to say was I don't know that we actually need the array thing anymore. Like, do we need this? Does anyone use it? I don't actually know if they do. So I'm going to find out if they actually do or if they don't. So here we go. Let's see. Brain slot index is less than array count. So I guess having the size there is nice, but I don't really know if that's the assert I want to use. And so this array right here, I think I can just call... I think what I, I guess what I'm saying is what I really want to do is I just want to say there's one entity star that's like the, array pointer. I should now just be able to specify that. And this way, I no longer have to guess what the maximum number is. Whatever the maximum number of things is in any of my brains will just be the size of the brain structure. And then we'll still access off of array, right? That seems like a much better idea to me. So let's go ahead and do that, because I think that's better. So in here, what I want to do is I want to just be able to map something into the brain. This is the only place that I need that. So what I can do is say, like, all right, give me the address of that pointer, and then I'm going to address the nth version off of that, right? And that should place it basically in the right location, right? Because I know this is the start of everything, and I can just move as many forward pointers as I want based on the index. So the only thing I can't do is assert that that pointer is in a valid area. But even that's pretty easy to do, because I can say entity star, and we're going to want to do this for another reason as well. And that is that C++, in its infinitesimal wisdom, and like this is like one of the worst decisions I've ever heard anyone make ever. When you're doing pointer arithmetic, if you don't do pointer arithmetic on U8s, C++ is allowed to just totally screw you and do the arithmetic entirely wrong if they don't come from the same memory allocation, meaning based off of the same sort of pointer granularity. So for example, if you were to do pointer arithmetic on something that's 8 bytes long, and you didn't have it aligned to an 8-byte boundary or some other thing like this, C++ is not guaranteed to do the arithmetic correctly. It's allowed to like substitute inferior arithmetic if it thinks it can get a speed win. I never ever want that, because if I cared about that speed win, I would do that addressing manually. But that's just the rules of it. In this case, I don't think we'd ever get hit, because since these things are 8 bytes long, that's a really trivial one, and it would never do any weird arithmetic because 8 bytes is very basic. But if you had something that was, say, 18 bytes long, that's where you might get into trouble. So anyway, what I want to do here is say, okay, I've got a U8 pointer, and I'm just going to take the address of this pointer that I've got here. Right? I'm then going to say, okay, I want that pointer to be advanced by however big one of these entity pointers is, times however much however many brain slots forward I'm trying to go. Then what I can do is I can just say, well, okay, the pointer to write to, right, is just whatever that pointer is, cast to an entity star dereferenced, right? So I'll just here I will go ahead and do my dereferencing, and I'll write to that entity star with the entity star that I have. Now what this allows me to do after I have the pointer is I can also assert that this pointer is inside the brain structure that I started with, right? So I can assert that this pointer is less than or equal to the pointer of the brain. And furthermore, I can subtract off the size of one entity star to make sure that it's not pointing sort of a little bit, like that the 8 extra bytes for the pointer isn't pointing off the end either, right? And so I should be able to do that. Size of entity, there we go. And replace all that code with something that now no longer cares how big it is. What did I do? Pointer, brain. Wait, what is it talking? What's the problem? Pointer, U8 star brain minus size of entity. Let me take a look at what's going on here. Brain. Oops. Index is 0. So my pointer is pointing to the same thing as the brain is, right? Oh, not quite, I guess, but let me see here. Ah, duh. When I said I wanted to point to the end, I have to obviously add the size of the brain. Duh. So I need to start where the brain begins, go to the end of the brain, and then subtract off one entity. And that's the furthest forward I should ever be. And so I can make my assertion back into what it used to be. All right. So that's more pleasant to me now. So I'm going to leave it that way. Oops. So by the way, like just to underscore kind of, I'm always complaining about C++, and so I like to kind of point out the reasons why I think it's such, it's so ridiculous what they do. None of that code should ever have to be written by a programmer. You should just be able to say that these things are overlays, and they're, different mappings of the same thing that I want to then access by an index. That's what you want your programming language to be able to do, right? You want to be able to have your programming language understand the concept that you may be packing multiple things in one place, and you want to be able to figure out what the biggest one of those things was, and then create an array of entity stars that's the one that you use to map those automatically. This is super, so basic. It's like one of the most basic things you might ever do in a metaprogramming environment. It's trivial to implement, very, very simple. But, C++'s mentality and the mentality of the people who upgrade it is always to make these systems that allow you to program in some way that they think is a good way to program or whatever. It doesn't even really make sense to me most of the time what they're really trying to do, but it's something like this. And so instead of allowing programmers to just write the code that they want and make that systemic, they want to enforce a system. So this is the kind of code, for example, I don't ever have to write at Molly Rocket, because when you are using metaprogramming as your basis, you've built stuff that allows you to just make this stuff happen correctly, automatically, right? But when you're forced to program in a language that's about people specifying policy, and especially when those people aren't very good at programming to begin with, they make bad policy, and then the only tools you're left with in the language are ones that enforce bad policy. And so it's really hard to do basic, simple operations like this. Like you saw all the weird stuff I have to do here. This is a very semantically straightforward, very basic programming operation, barely above what you would do in assembly language, right? And yet C++ makes it impossible to actually write the thing that you want, which is just how many is the most number of entity stars in the set that I have that I want an array of that, right, in this union. Sorry. We have no idea how we could ever write a programming language that would let you do that, right? And it's that sort of thing that I am always up against, I find. If you don't have metaprogramming, you're constantly doing these really basic things that are just about simply looking at what you've already defined, in a very, very straightforward fashion that really doesn't even involve much code, very, very simple code, and it can't do any of them. It's just like, and then of course you get the C++ people like, oh, well, you just make it into a template and you templatize it on the number of things there are, and then you pass that template to the other template. You're just like, what? No, it's 3 lines of code for me to write it directly. The thing that actually does it should be, at least that simple. Anyway. All right, so enough about that. Let's go ahead and make our snake, because that's what I wanted to do when I started. So, but I just want to clean up that part first. So if I go over to the snake piece thing, now I should be able to call the snake adder. So when I add the monstar, which I'm doing here, as you can see, I'm going to go ahead and add the snake. And in order to add the snake, I'm going to add I'm going to kind of stripe the pieces across the top or something. So I'll just say piece index equals 0 and piece index, is less than 1 plus piece index. So, to start out with, we'll just have one snake piece, and then when we get that working, we'll add more snake pieces, right? Pretty sane approach, I would think. And I'll need a brain for this. So, before I do anything, I'll have to make a brain ID here, but that's pretty easy. Just that. And then the segment index, I guess it's segment index, sorry. I don't know why I called it a piece. Add snake segment. So that's the snake. Now, all I have to do is decide where it's going to be. I'll put it vertically down the far side, maybe. So let's say it's on 12, Y. Ground 12, Y. And we'll just make Y equal to 4 plus segment index. Okay, and so if I create one of those, let's see here. If I create one of those, that's a snake. Wow, that is a very large snake head. That was not really the size that I had in mind. So I'm going to go ahead and make those snake segments a little bit smaller. That's just way too big. Way too big. So let's make that tinier. Okay, that's much better. All right. So now that I have those snake segments, I need something to move them around. And what I'll probably do is I'll use the exact same system that I used for the familiar. I'm sorry, the Monstar. So the Monstar code here, where it kind of searches in, I'm going to go ahead and copy that out. But we're going to daisy chain the movements. So what I'm going to do is I'll say, I've got obviously a head on this guy. So brain snake parts equals brain snake, right? And then what I'll do here is say, well, there's sort of the notion of the head of the snake is the first segment. And if I don't have one of those, then there's effectively no snake. Let's say. Just, that's purely whimsy, but that's what I'm going to say. And so in here, I don't know, what is this? Okay, so yeah, this will try to pick a direction to go, like, as it does. And it'll see if it can find a place that's unoccupied. And if it can find one, then it'll do this transactional occupy. All right. Then what I want to do is I want to basically have a for loop here, which if the transactional occupy succeeds, I just want to go through and make everyone do exactly that same thing, right, that they were doing. So I want to say, okay, the head will move 1 square, and then each segment behind we'll do the same thing. So we're going to start with segment index 1. We're going to go until however many there are in the, in parts segments. And then we're going to go ahead and take each segment of the snake. And if we have one of those, we'll do the same transactional occupy. And we really don't care if it succeeds or fails. It should always succeed because we know we'll be putting the snake into a place we just evicted another snake piece out of. And if for some reason it failed, well, that just leaves the snake piece in a different location than we thought it would be, but that's not really a problem. So I think that's fine. All right, so when we do transactional occupy, we want the segment to go from its occupying to, the last occupying kind of a thing. And I want to save that traversable reference here, right? So that's the one we were in. We go to this one, and I basically set, I record whichever place we came from so the next person can go there, right? Similarly in here, we do, oh, well, you know what? Body came from is what that is already. Well, I guess it doesn't matter. So we're just going to say here that last occupying equals wherever the body is right now, like so. And yeah, this transactional occupy, I guess we can, excuse me, do the same thing here where we just say like, okay, whatever the T movement, whatever we were doing, we'll do the same thing to the segment here. So body came from, I guess we can literally just do this. And this looks like very shareable code, so I think I'll probably end up making some of these into utility functions. Let's see here. Sorry, I just got to clean this up. There we go. So that transactional occupy, and then we'll launch this guy off into his movement, right? And I don't know. Body occupying, movement mode, segment index, segments, blah, 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 blah. So I think that's all fine. So all of this stuff just has to be switched from body to head. Okay. Oops. And yeah, need to actually set that in here. All right, so that is exactly what we would expect, right? Because it's gonna behave just like a Monstar if it doesn't have any additional information. So now let's see what happens though if I create, when I do an add snake piece, we don't, the interesting case is when I add more of them than just one. So we want to see if we can get it so that they are properly following each other along, right? And that actually does seem to be working just fine. Okay, so let's try adding a lot more of them. 8 might be too many, because I guess in the Y direction that would leave us with some that are embedded in somebody's current standing place. So maybe I should do this as an X thing instead. So maybe just to make it easier on myself. So, it's like an X is 2 plus segment index, and that way I can do like 12 of them or whatever, right? Oh, except I don't allow snakes that big. Said so right in my thing. Well, all right, maybe we do allow up to 16 segment snakes or something. Yeah, so that seems to work just fine. I might argue that you know, people probably shouldn't be moving diagonally, right? And so when oh, our snake like locked up its head, its own head. That was funny. That was pretty funny. It can't. There's no way it would ever get out of that. That's so funny, right? Because this is the head, and in fact, you know what? Let me just demonstrate this again because that was kind of funny. And if you can't tell which one's the head, it may be hard to know what's going on there. So I'm going to do add snake p segment there. So here's the color information. So what I'm going to do is I'm just going to take the segment index and I'm going to make the front of the snake be like colored differently than you know, as the snake goes further, basically. So you know, I'll do something like oh, actually, you know what I'll do? I'll do this. If the segment index is not the first, then I'll make it a torso. Otherwise, it's a head, right? That's a lot more straightforward, right? So there's the snake, like snaking around or whatever. And if it can get into a situation where it's wrapped around itself tightly enough, then the head cannot jump to any other location, and that will be it. That snake, like here, it can still eventually jump out because there was one square, but at some point, it will curl around itself enough that it can't jump out. And then, here we go. So there you go. So you can see here, right, this is the head of the snake. There's no empty squares, and it's just, that's it for our Mr. Snake, which is kind of cool. That's pretty funny. So yeah, so that all seems to be working great. Actually, that was really easy, which is what I want. And you can see I can still not sort of access any of those. All right, so I feel like that is a pretty good testament to the fact that the brain stuff seems to work really well. Like, that was super easy to do, like, you know, and it doesn't require any statefulness. There was no, like, persistence stuff. You know, no reference counting, no lifetime management. You just add a bunch of crap and say it's a snake and you get a snake, which is what I wanted. And when you delete, if you were to kill one of these guys, I think it would be pretty trivial as well. You'd just renumber the snake, like an array deletion, basically, and I think that would be it, right? Or don't, for that matter. So I think that's pretty cool. So I think it should be okay. So I think it's really the movement mode stuff to concentrate on now. I should also look to see what happens if everything scales up okay. Assuming it does. We have a lot of n-squared-y things in there right now that we need to, because we don't have a spatial query yet. So we can't create a lot of stuff without having problems because of the spatial query. So that's something we're going to have to take a look at too. Just be warned about that. But I just want to see if I create some additional screens, what happens here. I just want to make sure that it's all good. Yeah. I want to make sure that, you know, there's stuff happening and, you know, nothing weird is going on. Yeah, so that's all fine. That seems reasonable. I should probably get that row of trees out of here because I can't move through there at the moment. Why is that row of trees there? I think we were testing something about hopping over the walls or something like this. Yeah. Is it tile x equals 14? That looks like. Yeah. And so you can also see that, you know, having all of these people do all these queries, like we should see that in our profile, that our simulation time is just really bad, right? And I mean, this is a debug build, so yeah, we could get around that by just compiling in release mode, but you know, I mean, it should, for this few things, we should have no trouble handling it, and the fact that we are spending that much time is just a good indication, and I guess I shouldn't be premature and say that I know exactly what it is, but doing that many n squared spatial queries is just going to be unacceptable. I assume that is the thing that is unacceptable already, but you know, if it wasn't, it would be eventually, soon enough. So that's something that we also want to take a look at relatively soon. And yeah, so you can see we're missing we're not 60 frames a second, we're 30 frames a second at the moment, in fact, right? Well, even without that on, you can see that it doesn't quite hit. It's we're up around 18 because it's simulating the snake in the next room over and all that stuff, and that's just doing tons and tons of spatial queries for no reason. So what I might suggest as well is maybe we want to look at that. Let's see, it's 6 o'clock, so we've got about 15 minutes. What do I want to tackle? I think I want to do movement mode because I think we should probably save the spatial query stuff for a little bit later. But that's definitely a good thing to do because we're gonna have a lot of spatial querying stuff that we want to do, and we're gonna want to put something in place there that's nice and zippy. So I'm gonna leave this. I'm gonna crank it up, in fact, a little bit more. Although I don't know, maybe we can't really crank it up much more because we don't simulate stuff that's far enough away. So like we can't create arbitrarily much work because we only simulate the things that are nearby. So, you know, at some level, we're not actually simming. I'm going to just drop out here the camera. I'm going to use the debug camera. So you can see that it's not simulating the stuff outside the sim region. Here's the simulation apron, I think. Well, actually, no, that's correct. Because this guy, it is simulating this guy, and it would be simulating those two, but it won't simulate these, right? And so as I move closer, and these come into that cyan region, they start simulating. Now, these aren't simulating because their head is not in the region yet, and the head is the thing that makes the decisions, right? So there you can see now these guys are no longer moving, right? And you can see that we kind of have a bug there, too, that we have to figure out how we want to handle. Or do we? Well, I think we would have a bug. I'll put it to you that way. I think we would have a bug, and the bug is that we would not... when we move people in... if you have a multi-piece entity like a snake, you might get a situation where the head could move and the body was not in the simulation region. So I'm not sure how we want to deal with that, but you can see why that would be a problem, right? So that's something that we should probably address as well. Let me see. Let's watch. I should be able to get those bugs to occur. But that's a good thing. I hadn't thought of that, and that seems like a good thing to get right. All right, so let's start moving out of here and see what happens. So this guy has unfortunately locked up right at the entrance. It's okay because we're not blocked by him yet since our head can float over. I really need a case where the head can move but the body can't, which I'm not super able to do. Okay, there we go. You saw that happen, right? Yeah, but it's not quite enough. I just need that guy to, like... go the other way! No. He's not gonna do it. Well, point being, we have a bug. I'm pretty certain of it. It's a bug that's a little bit hard to make happen, right? But yeah, when you have entities that are spatially fairly large, there's sort of a notion there of like how we would handle that apron region. And I don't know. I do not know. One way to do it is to always pack entities into the location of their head, right? So you could sort of do some kind of packing scheme where you always put things into the room where the head was, even if they were outside that room, so that you knew that they always got picked up together. That's one thing. I don't know. Since things in this game are room-based, I don't know that we really care all that much. But it's something that I just would like to think through because, you know, like I said, I kind of wanted to try some interesting, weird things with this entity system. So I don't just want to ignore something that might lead to an interesting concept, if that makes sense. So I'll have to think that one through a little bit more. I'm going to have to put that on the to-do list because otherwise I might forget what that problem is exactly. But, you know, while it's fresh in my head, I'm going to write it out. I do think one thing that's kind of cool that I guess I would say we want to encourage is while I'm standing here, in theory, the snake from the room above us can come down into our room because we are simulating it. And so that is neat and the kind of thing that I would like to have happen in the game so that things in nearby rooms aren't turned off entirely. You know, like, yeah, okay, so our snake just left, for example. And the monster, wow, everyone left. All right. I guess we're just not that popular anymore. So the snake leaving, I assume it's simulating up there and could come down if it wanted to, right? The fact that it hasn't, I don't know if I should be concerned about. Let's see. One of them's locked up. That's why he didn't come down here. Oh man, that snake is just leaving all the time. And of course, now that snake has run into the other snake and deadlocked. Right? So it can't go anywhere now. That's pretty funny. That's hilarious. So yeah, all right. Well, anyway, point being, I think that's all good. The only thing that I'm concerned about is I just don't know what to do about that notion of how we do the gather. One thing we can do is if we know the maximum spatial extent of an entity, we know whatever that ends up being. I suppose one thing we could do there is just say, well, if we know the maximum spatial extent of an entity, we can make sure that if we see a particular entity of a given type, we expand the search for entities of that type to a region that's wider than the region we're gathering, right? So that seems like a reasonable solution. In fact, I think that may be the brightest solution. Stop attacking me, snake. Yeah. So here's what I think we should do. What I think we should do is when we're doing our chunk searches, let's see here. So when we're pulling out the chunks, I guess what I'm thinking is when we stream, well, yeah, see, that's not that great either. I don't know. This is a doozy. I was gonna say because I think it's very efficient to be able to kind of stream in chunks, and then stream them back out. And you know, if I do something where I expand the search region, I have to start looking into chunks that I don't necessarily want to stream out the entire contents. So that just seems problematic. I guess what we could do is say that any entity with a certain radius, like here's how many grid squares it could be away from itself. You know, we don't want to let them separate, so we're going to only simulate it if it's at least that far in from the simulation boundary. Still not great. So I don't know. That's kind of annoying. It's a thing we only have a problem with where we have geographically like dispersive entities, but it still kind of seems like a bad situation. So I'm gonna put that in the to-do list. Let's see. Yeah. I guess we did the rudimentary behavior examples and stuff like that, but we still want to do pathfinding. And AI storage, I don't know how much we're going to have of that, but we should do like with these are the same thing basically. Well, maybe not. So I don't know what AI storage would necessarily, how much state we'd store for AIs and where they would necessarily be stored. So I suppose that's something that we should still keep in there. And yeah, this we did. We know what the entity system is now. But the rest of this stuff seems pretty reasonable. Sword collisions are not going to be a thing. Yeah, and a lot of this stuff, really, this is probably not going to be... Yeah, a lot of this stuff is not really going to be the way... I'll leave them in there for now, but a lot of stuff's not going to be the way that we talked about it. So yeah. Anyway, we've got on the to-do list... I'm going to put an entity system thing here, which is basically just that what to do about geographically disparate entities that might only partially get streamed into a sim region, but which need to move together as a unit. Because that, I don't know, we could just say we don't handle that right, and it's fine. Every system has limitations, so, you know, that's okay. But maybe we want to try and see if there's a good way to solve that problem. All right. I'm going to end it there, and I think maybe we'll do spatial queries tomorrow, because I think that's a good idea. And maybe movement mode stuff. We'll see. But I'm going to go ahead and go to the Q&A for now. Bad Fly Dog, wasn't today an off day? I don't think so. June 1st, 5 p.m. Right? So it wasn't an off day. Can the compiler really mess up the pointer arithmetic? I mean, it is just integer ops. Can't be that hard to mess up. Well, it's not that it messes it up. It's not like it produces erroneous code in the sense of the spec. But the problem is the spec says it's undefined what happens if you do that. That's the problem. And when compiler vendors see the word undefined, they take that to mean do whatever you want so that you can have the fastest benchmark scores, rather than seeing obey the principle of least surprise, which is what I think it should mean, right? And so you get a lot of these situations where compiler writers will decide that because the spec says something is undefined or unspecified behavior or whatever, they can just do whatever they want. And, you know, I don't really necessarily blame compiler vendors. I would wish they wouldn't do it, but I really blame the spec writers. Because what the spec writers should have written is they should have written something that's specified in all cases, and in any case where they can't specify what needs to happen, they should say something explicit like, this will, you know, in the case of doing signed arithmetic, the result will be whatever the processor would do if it was going to subtract these two values. You know, it should say whatever the programmer would expect the processor to do on the target platform or something, right? So rather than say it's undefined, do whatever you want, it should be more like, no, it's specified as much as humanly possible, and anywhere that we can't specify it, we specify you must obey the principle of least surprise. You can't just not work or generate bogus code in those cases. You have to generate code that would do what the programmer might expect the CPU to have done, rather than expecting, you know, something that no one would ever expect it to do unless you were a compiler vendor. Longbillion, is the way to fix the snake from getting stuck to just allow it to run over itself, or to make the snake AI smart enough to not trap itself? So I would say, first of all, snakes probably won't generally be that long, so the problem is probably exacerbated a bit in the current thing where we were just testing it. Excuse me. But the AI would generally probably not be randomly picking, so it'd be less likely to get into that state. But B, if it could get stuck on itself, I'd say that's actually fine. That just means, hey, you can kill it really easily. Like, just go up and wail on it or whatever, right? So I wouldn't even necessarily say that's a problem. Like I said, the AIs in this game are supposed to be about being predictable and interesting, not about being really smart. Because I don't think that really adds anything to a game like this. So I would rather it be like if the snake occasionally gets caught, like, awesome, that means I can kill this snake really easily, whereas normally they're much harder or something, right? I've recently watched your video on the GJK algorithm. It's great. Thanks for that. You're welcome. Did you also do a video on the EPA algorithm? What is the EPA algorithm? The Environmental Protection Agency? I don't think they have an algorithm. Sir Kane, will the snakehead be able to move to the position of its last segment so it can go in a circle or loop? We could allow that, certainly. But I don't know that I care about that enough to implement that, but you certainly could, right? You just transactionally deoccupy before you did your search and then reoccupy after, right? Sean McGrath is expressing surprise that I did a video on GJK. Yes. I did a video on GJK. What other explanation videos have you done? Well, you knew I did a quaternion double cover one, right? Parajanan, are you going to implement every AI thing in Brain Entity? When does pathfinding and rest of AI coming on schedule? Also, can you say some good reference book for AI? I cannot say that I know any good reference books for AI, so I can't help you there. As for if I'm going to implement every AI thing in the brain, yeah, basically like brain.cpp will probably have all of the control logic in there. And what we'll do is, like, right now, you can already see it starting to happen, and so we'll make this a reality soon enough. Like, these sorts of pieces of code are very self-similar, so we'll be breaking these out into utility functions so that, this isn't, so it's not so complicated to write one of these, right? So instead of having to do something like, oh, find the closest hero manually, there'll just be like a simple call that's like, get closest of type blah, and then hop towards blah, right? And the brains will just be built out of those utility functions, basically. So those are pretty straightforward, and that's how this thing will go. As for when they're on the schedule, we don't have a schedule. Game development rarely operates in a rigid fashion in that way. You have to work on what makes sense to work on at the time. So I have no idea when we'll do various AI things, when they come up. When it is most logical to do them from the architecture standpoint of the program is when we'll do them. Sean McGrath said, yes, and I am GUI, but what else? So I don't think there's many others. I think there's one on Bezier splines and how you can understand how they're actually constructed, and how you, for example, don't have to look up the formula in a book. You can just always derive it yourself really trivially by just remembering that it's all linear blends all the way down. So I did one on that, but I don't remember if there's any others. Expanding polytope algorithm. Oh, okay. No, I've never done an explanation of the expanding polytope algorithm. As you can imagine, if you apply the same logic that I applied in the GJK video to the expanding polytope algorithm, you should sort of pretty readily see how it's a very geometric algorithm. But if I remember correctly, expanding polytope is a little messier. GJK is very, very simple, and I seem to remember EPA being slightly less simple. But yeah, if you're looking for those old videos, they're really old, but you can go to youtube.com user... can you do Simuratori? Probably not. That is not me. All right. YouTube Casey Muratori. Okay, so it's Casey Muratori. So here's the videos. So these three here are the ones that were old videos. This one's a newer one. And I think those are the only ones. So this one, this one, this one, and this one. Yeah. And these used to be up on my other site that were directly, but I uploaded them to YouTube now, so you can get them directly off of here. But could you briefly explain how a snake segment knows which node to jump to? A non-head segment, that is. So, oh, someone just said don't forget the API segment. You're right. That's a good point. There is one other one. This one, designing and evaluating reusable components. So there was one other one that I forgot to mention. Sorry about that. All right. Anyway, so the way that snake code works is really pretty simple. All it does is it uses the Monstar code like you saw. Where is it? It uses the Monstar code to just figure out where the closest traversable is to the head that's not occupied, right? It then says, okay, jump there. Then all it says is, well, all right, I've got some number of segments that follow me, so just loop through every segment and tell that segment to jump to whichever place I was just at, and that continues down the line. So the head is leaving a square, right? This is the square the head was occupying. It's going to leave that square. So that goes into last occupying. Then we just loop through every segment and say, okay, this segment goes to that, right? It goes to that place where the head was. Then we say, well, replace that last occupying variable with wherever we were. So every time someone leaves, it remembers where it left and tells the next person down the line to hop to that. So it's just like a bucket brigade. It's like every segment of the snake leaves a place and tells the next segment to hop to that place. So they just hops, each one hops into its own position. Busy Beaver. Well, I've got GJK and EPA implemented in 2D and GJK in 3D, but I'm a bit struggling at EPA in 3D. Yeah, well, yeah, that's reasonable, right? It's a lot more complicated in 3D, just like GJK. Conceptualizing the cases in 3D for those algorithms is just way harder in 3D because there's way more different types of constructs, right? So. All right, looks like we're done with the cues. I don't see any more coming up, so I'm going to wrap it up. Close. All right, thank you everyone for joining me for the episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along at home, you can always pre-order the game at handmadehero.org, and it comes with the source codes for your educational pleasures. We also have a forum site you can go to if you want to ask questions, a Patreon page you can go to if you would like to support our fine video series, a schedule bot that tells you when we are live, and of course an episode guide if you would like to catch up on past episodes. That is it. I will be back here tomorrow at 5 p.m. Pacific Daylight Time when we will probably do the spatial query or movement mode stuff. I'm not sure which of those two we'll do. You know what? Movement mode. We'll do movement mode tomorrow because we gotta make a floating movement mode and we want to solidify the other movement modes. So we'll try to make movement mode a more specific thing. And maybe we'll try adding one more type of movement, like maybe burrowing through the ground, for example. So someone who doesn't really collide with stuff at all, but can move from place to place would be another one, or ghosts, like that kind of thing. So we can try to make different movement modes that make sense or something like that, and kind of solidify that down, because that's just something we want to get right. So that's about it. Hope to see you there. Until then, have fun programming. I'll see you guys on the internet.